Assalamu alaikum warahmatullahi ta'ala wabarakatuh. Ladies and gentlemen, welcome back to another live stream. This is part 2 of this series. So let's go ahead. I'm gonna share my stream, make sure the stream is in a good condition, and then we're gonna start. Also, I'm having a new concept, which is that you could actually join me on VC while I'm streaming. So my mic is off, but people can actually hear the ones that joins me in the stream, and of course me too. But the people that joined my VC would have to actually watch me and hear me from the stream itself. But yeah, desktop audio mic, great. Okay, seems good to me, I guess. And let's see, everyone. Okay, let me make sure the URL is correct. There you go. Great. Okay. Live on YouTube. Let's go. All right. Seems good to me. The quality of the stream seems fine. Great. Okay. So let's get started. All right. Let's see. So last stream we have basically created a triangle, and of course we have set up WebGPU Dawn implementation. And today we're gonna be doing buffer stuff. So we're gonna be creating vertex buffers, index buffers, etc. I think. Yeah, pretty much. So yeah, let's just get started. I think. Let's go. And actually, before that, I want to do something pretty quick when it comes to our code here, which is this async stuff, like on the adapter request and on device request. This seems so bulky to put it in its own member function. I'd probably turn this into, let's say, into closures instead, honestly. So yeah, let's go ahead, comment these for a second. And let's see what we gotta change. Though let me make sure the app is working for a second. And also before that, I'd like to probably make a Git repo on this, but let's see. Take some time to build. All right, let's go. So as you can see, it actually works. Nice. Now let's actually comment these out, basically. And let's see what we gotta change, essentially. Let's see. So request adapter on adapter request. Yeah. So let's go to app HPP. I should probably comment this out too. And let's go. All right, great. Now let's actually create the callback. Let's go. So basically you're gonna get this, and here you're gonna get the data. It's probably gonna be void, I think, isn't it? Well, you're basically gonna take these. All right, let's go. There you go. That's what I'm talking about. And then we could essentially go ahead, auto app static cast on request adapter status. Let's go. Failed to request adapter. Nice. And app adapter, WGPU adapter. Amazing. That's what I'm talking about. Let's go. Nice, nice, nice. All right. What else? Let's see. Request adapter status. Great. Okay. So now let's change the other one on device request. It's going to be very, very similar. So we're going to create a callback. and we're gonna actually copy the signature that we got here, and let's go. There you go. And yeah, now of course auto app, static message, blah blah blah, and finally app device, WGPU device. Let's go. Hopefully this would work just fine. It should be. Let's see. And yeah, it works. I think this is much cleaner. Let's go. So we don't need these member functions anymore, which is nice. And then we also have app.hpp. Let's remove these. Okay, so right now let's go ahead and try to create the buffers essentially. Okay, let's go. Oh, I forgot about the, oh well. Okay, let's just see. All right, so where are we gonna start? Let's see, creating a buffer. So we have to create a buffer descriptor with copy destination, copy source, and size, and map that creation false. Create buffer to a specific part of CPU side RAM. The driver then automatically synchronizes its content either for reading or for writing. Will not use it here. Buffer, create buffer. Here, what kind of buffer he's creating? Oh, I think it's just showing up like how do you actually create a buffer generally. Yeah, so numbers, q.write buffer. I see. Anyways, copy, usage, blah blah blah. On buffer to map the synchronous polling, blah blah blah, mapping content. Anyways, so now we need first vertex attribute. So here he's gonna change the shader, then it's gonna check out the capabilities. I see what he's doing there, though we don't need this for our small application. And yeah, vertex buffer, let's go. So here he's actually creating the vertex buffer. So this is what we actually need now. So for now we hard code, and there you go. He actually have used, oh never mind. So did he change the shader? I think. The term attribute. Well, anyways, let's just create the buffer now. Yeah, let's just create the buffer. So buffer size, vertex data size, okay, and then the usage. Buffer usage, copy DST, vertex, and then map that creation equal to false. And the vertex buffer, create buffer, great. And then he upload geometry data to the buffer using the queue, great. Okay, makes sense. Vertex buffer layout. Then of course he changed the layout, and then vertex attribute, shader location, great. Format, the offset, the erase stride, the step mode, vertex or instance, and then finally the render pass. He said the vertex buffer. Okay, let's try to do this. Same triangle as before, except now I can very easily add some geometry. Great. So let's actually just copy this vector right here, this data, and let's go. So where are we gonna do this? Let's see. I guess maybe after compiling, or maybe after starting the compilation process, possibly, or before. Well, not yeah, actually before the pipeline. Yeah, before the pipeline. Let's go with that. So where we are after the device, great. And let's go. So std vector, vertex data, float. Well, I would honestly change this up a bit. I would put this in a struct, right, called Vertex, for example. Struct Vertex, and it would have another, we also need another struct, maybe called vector2, though I wonder if WGPU have such a thing, for example. No, it doesn't seem like. So let's just go with our own little struct for now, maybe. Or honestly, it may be about time to actually add GLM, because we're gonna need it eventually. So let's go ahead and do that. Let's go with GLM. Okay, great. So there you go. Okay, great. So what is happening here ahead? Okay, forked. Great. So this is g-truce or truce / glm. So you're gonna need this guy, and let's go. So you're gonna add this library into the mix, so don't reinvent the wheel when it comes to math. cpm add package, and here it can just say, since it's from GitHub, we could just do it like this, I think, if I remember well. Yeah, glm, and then we could give it a tag. I'm just gonna go with the latest tag, why not? And yeah, that should add it, and of course I gotta link to it. Let's see. And now it's gonna add it. It's gonna go ahead, download it, add it to our CMake, and then of course link it. Yep, seems about right. So now what we could do, we could go ahead to, let's say, app HPP, and let's actually include what is it called, glm /glm.hpp, I guess. Yeah, there you go. So as you can see, we have added that, and now we would have access to that stuff. So struct vertex glm, let's say vec2 position. Great. So struct vertex, rename to vertex. Let me disable this inspection, I don't care. And let's go ahead here and say, well, in fact, maybe we could just do it like this. All right, great. So as you can see, we have this now, this vertex data. Now we got to create a buffer. There you go. That's what I'm talking about. And let's see, map that creation, that would be false. Buffer usage, that may be interesting. Let's see. And WGPU buffer usage, vertex. Yeah, what's up with that? Oh, you have already initialized that. Okay, I see. Makes sense. So yeah, that's it for the descriptor. Now let's actually go ahead and create the buffer. And this is totally wrong, so let's do it ourselves. But should I store this buffer? I wonder. I would guess yeah. So let's go to app.hpp. And before the shader, let's go to WGPU, I guess, vertex buffer, and we're probably gonna need index buffer at some point. And yeah, so descriptor, nice, and we could just call this data. Or honestly, I would like this vertex data to be more available to everyone, so I could do stuff with it. So for now, I could just put it as kind of global, because it's just static. It won't change, I think, for now at least. So use of indeclared identifier vertex. Yeah, let's grab the struct vertex here too, same thing. and yeah, and this would basically be const expr, I guess, if possible. Oh, there's no need to make this a vector though. Interesting. Array, comma 3. Does that work? Let's see. No viable conversion from double to GLM. Oh. Should I like make this float or something? Weird. Okay, let's see. What if I done this? Let's go. There you go. Nice. So say vertex dot position glm vic2 and let's go. So we got this vertex data now. We're probably gonna need vertex indices too soon, but anyways, so here we got the buffer. I wonder if you could like just get the size of an array in bytes, huh? C++ size of array in, like, without doing this size of vertex times vertex data dot size. I wonder if there's like a way to do it. C++. Alright, how to get the size of an array in C++. No, I don't think so. Doesn't seem like there is a way for now. So anyways, so let's create a buffer now. Nice. And next up, if not vertex buffer, then we have a problem. Failed to create the WebGPU vertex buffer. Amazing. Next up, I don't think this is correct. Yeah, we gotta use the queue for that. So here we gotta say write buffer, right? So we gotta give it the vertex buffer, then the buffer offset. Interesting. It's gonna be 0 here. Basically, you could use that for sub allocations maybe. But anyways, vertex data dot data size of vertex times, for example, to like, let's say, store the indices and the vertices in the same buffer, for example. But anyway, size of vertex times vertex data dot size. Great. Times vertex data dot size. Okay, nice. So what's next? So now I think we have created a buffer and wrote the data to the buffer. Amazing. Next up, we would change the pipeline attribute so we could accept that vertex buffer and actually interpret the format of the vertices. Okay, so how are we gonna do this? Let's see. So we got descriptor, fragment state, blend state. Okay, so here we got vertex, yeah, so maybe that's the thing. So here we got buffer count, it's gonna be 1, and we got buffers, and of course that's gonna be, well, honestly I'm just gonna go with, let's see, I'm gonna make an array here, honestly, and I'm gonna call that buffers. So type name is gonna be, well, WGPU, I guess, buffer, but not the buffer itself though. It's just gonna be like an, I guess, well, not really, yeah. It's gonna be what? Hold on, buffer. Oopsies, hold on. The buffer, what type? Vertex buffer layout. Okay, so it's gonna be an std array of vertex buffer layouts. Exactly. And here we're gonna need the array stride, which is size of vertex, attribute count. Okay, so here we're gonna make another array called attributes, WGPU vertex attribute. Though this probably should go into its own vertex struct actually, but anyway. Vertex attribute, comma 1, and this is gonna be the vertex attributes. Let's say, oopsies, though this is bad. Okay, and WGPU vertex attribute format, WGPU vertex format float 32 times 2. Oh, times 2, you sure about that? Yeah, are we using Vic2? Yes, we're using Vic2. Otherwise, well, yeah, that's good enough. So the offset, of course, 0 because it's the first attribute. Then the shader location 0, I think, is maybe fine. Let's see. We'll see. Anyways, so vertex attribute, great. Now we could basically say attribute count is equal to attribute dot size. Well, vertex attribute dot size, then attributes is the data of that. What else? Is there anything else? Step mode, yeah, vertex. That's gonna be vertex. So WGPU step vertex step mode. Well, vertex step mode vertex. But it's yelling about the order here. There you go. Great. That's what I'm talking about. Though we could make some sort of function, let's say, to map the attribute to the correct vertex format, but right now it's fine hard-coded. Okay, what's next? Buffer count. Vertex buffer layout. So here we're gonna say vertex buffer layout.size, and then here I'm gonna say buffers vertex buffer layouts. And now let's see, is there anything else I'd like? Let's see. So we have buffers, constants. We're not using any constants currently. We could use it, for example, for time. I think that's probably it. And the next thing would be to essentially use the vertex buffer in the pipeline. So if we go to the, in the render command buffer or whatever, render command encoder. So let's see, render pass, set pipeline. Okay, great. So we could basically set the pipeline, I guess. Not sure if the order matters here in this case, but I'm gonna set the vertex buffer to 0. So there you go, and then I'm gonna draw. So now we probably gotta change the triangle. So let's see how that would go. So I'm not very literate about WGSL, so let's check the tutorial. Let's see how they've done it. Yeah, in vertex position and then location 0, instead of taking the vertex index and using that essentially. So let's go with that. So instead of built-in vertex index, we don't need that anymore. We're just gonna go with location 0 in vertex position vec2f. And then here, instead of this array, we could probably go with in vertex position. Well, that's a vec2f, so we could probably go with vertex position like this. Position, right. I think that's correct. Yeah, it is. Nice. And oh, I missed yeah, I missed something here. It's comma 0. And there you go. So let's hope this works. Let's see. And we got nothing. Let's see why. Alright, the first thing that I would suspect when I see an empty triangle is the order. Is it counterclockwise or clockwise, and also the data. So let me actually use the tutorials data instead, just to make sure. So where's the data? There you go. So it's minus 0.5 minus plus plus. So well, let's just copy this for a sec, and let's put it here. Just gonna comment this out. And yeah, so first thing first, minus 0.5. Okay, here it's plus 0.5 minus 0.5, and here 0.0. Well, it's actually the same thing that I have here. So something is interesting is happening, but we don't get any errors for some reason. Oh well, let's see. Failed to request WebGPU device. Am I missing something? So we're creating the buffer, then we're writing to the buffer. Is there any interesting warning? Render pipeline descriptor. I don't think. So not sure what's wrong here. Let's see if we have done everything correctly. So Vertex, main in Vertex position. So we have changed the shader to do that, which is nice. Next thing, they're getting some limits. We don't need those right now. Required limits. Oh, hold on a second. Required limits. There is no requirement. Required limits default. Yeah, no need for that, I think. But it could maybe improve performance since we're telling it exactly how much stuff we need there. But I don't think that's the problem. Here we got the vertex buffer, vertex count. Hold on, what? Static cast int vertex data dot size. What? For now, I hardcode the value of the vertex buffer. Oh, I see why he's doing that. Okay, vertex data dot size times size of float. And oh, he also have copy destination here, so we could upload the data to it. Maybe I'm missing that. So let's go to where we're creating the vertex buffer. Vertex buffer, let's see. Okay, create buffer, if not. Alright, usage. So let's add this usage. Copy DST, though this would be WGPU buffer usage. Copy DST like this. What is next? Size of vertex times vertex data dot size. Great, I think, yeah. And create buffer, write buffer, size of vertex times vertex data dot size. Correct. Vertex data dot data. Okay, so is there anything else that could be missing here? Let's see. Rich. There you go. Okay, so that's what we was missing basically. So copy DSC and we got a triangle. Amazing. Let's go. I really need to find out why the debugging doesn't work. Like when something goes wrong, it just doesn't say anything. But anyways, triangles rendering using a vertex attribute. So right now I could, for example, add these guys here to add another triangle, though we would need to change something actually to make this work. But let's see. So if we add this, essentially vertex position. What's happening here? Oh yeah, because this should be 6. And let's go. So let's add some more triangles here. And of course this wouldn't actually work out. because we're not drawing all the vertices just yet. I'm gonna show you why in a second. As you can see, we only have one triangle. But if we go to the draw command, in fact, there you go. Here we got the vertex count, so we could actually check, use this as vertex data.size. The instance count, we only have one currently, so, and this should hopefully maybe fix it. Let's see. And we should be able to draw multiple triangles. Let's see. Oh, we're only seeing one triangle though. Maybe the data is not right. So let's add that. Let's use the ones in the tutorial just to make sure. And let's see. Okay. All right. There you go. We got a second triangle. Amazing. Let's go. Lovely. Nice. And that's how you create multiple triangles. Love it. So let's go. Now we got a vertex buffer. I guess maybe let's try to do an index buffer ourselves, maybe. So let's check that out, I guess. Let's see. So const expr std array vertex 6. Now we're gonna have a const expr. Let's see. There you go. That's what I'm talking about. We're just gonna go do int 16. That's fine. And 6 vertices. This is fine. Yeah. All right. This is our index data. Now let's try to figure out how to do an index buffer ourselves instead of depending on the tutorial. Let's see. So the vertex buffer, there you go. I'm gonna do a very similar thing to this guy, but it's gonna be an index buffer. And of course index here and create buffer. This would be index buffer, and we gotta create a field with that. The white's not complaining. Interesting. Weird. Anyways, so the scripture, instead of vertex, is gonna be index. We still gonna need to copy this destination to actually copy to it. Great. And instead of size of vertex, we're gonna go with size of, well, we could do something interesting, which is indices or index data. We could say type, I guess, if I remember. No, probably, yeah, decal type. We gotta say decal type of index data type, I think. Yeah, value type. So we could get the underline data type, I think. Yeah, there you go. That's how you make sure that it works. Great. Vertex data.size. So basically, if we change the index data type, underline type, then this is going to be automatically changed, which is nice. So what else? Index copy dst vertex. Oh, not vertex. Index data.size. That's why you should probably avoid copy pasting. There's just a lot of stupid things that could happen wrong. But that, there you go. Index buffer. Index buffer. Oh my god. Index data. And here size of, well, honestly, let's just say size in bytes, I guess, or something. Yeah, let's say autoconst size bytes. Let's actually use this little thing. There you go. And now what? So this size bytes would go simply to here. And let's go. Let's go. Size bytes index buffer data. Let's go. Okay, we could do something similar here actually, which is to just say something similar to this, but instead of index data here, it would be vertex data, and vertex data here too. And finally, we could just say size of bytes here without too much duplication. And yeah, that's it. Now I gotta add this field, an index buffer. Yeah, I've already done it. That's why. Interesting. So that's it to actually create a buffer and upload data to it when it comes to index buffer. Next thing we would do is we need to change the way we draw, and we need to also maybe possibly set the index buffer. Not sure. There you go. Let's go. That's what I'm talking about. Here we could say index buffer, index data. Well, index data. Oh, hold on. What this takes? Oh, well, never mind. This should take uint16 for now, and draw vertex data.size. Okay, so instead of a draw, we should probably use draw elements or something similar. Yeah, draw indexed. You give it the size, and yeah, that's pretty much it. Nice, and this should hopefully work out just fine. Great. So yeah, if I didn't miss anything, that this should work just like before, but right now we're using an index buffer. Let's see. And there you go, it works. So right now we're using an index buffer. Pretty cool. First vertex attribute. Now let's check the other ones. So right now we got multiple attributes. Great. Right. Hold on a second. Okay. So you may have guessed that we could simply add a second argument to the vertex shader entry point with a different location. Yep, this works, but you might prefer when the number of input attribute grows to instead take a single argument whose type is a custom struct labeled locations. Yeah, we have already done that here. Sorry, here. Yeah, there you go. I've already done that, I think. Actually, we haven't. Yeah, we have done it for the vertex output though. Yeah, I see. So we could do it basically for the vertex input too. So you create a struct, and then you say location, and yeah, you just take that instead. So let's try to do that. So struct vertex input. I like this. Let's oopsies. Yeah, built-in position. Well, not built-in position. Would, isn't it? Yeah, no, location 0, because right now, yeah, basically location 0. Position, well, in our case it's gonna be vic2, because we're only giving a vic2. And then instead of taking this, I guess we could take vertex data, is it? Or what? In, they're just calling it in, okay. So in is vertex input. And so here we gotta do in dot position, I think. And yeah, that's much cleaner. Let's go. Nice. Let's go and let's see if this actually works. Amazing, perfect. One thing that I have that is kind of irritating is the fact that the app starts but you don't see anything for some time. There you go, as you can see, and then it just renders in. So what I'm gonna do, I don't want to show the user the window while even the render haven't been created yet. So what I'm gonna do actually is I'm gonna find out a way to hide the window by default. Maybe GFW window hint, I'm not sure, let's see. GFW, it doesn't seem like there's a window hint, but I guess we could say just window.hide, GFW hide window. Let's go. That's what I'm talking about. And now, and then after we are ready to start rendering, we could actually show the window basically. So after all of this craziness, yeah, once we're done, we could say GFW show window. And let's see if that improves it. Let's see. And yeah, the window only shows up when it's actually ready to start rendering. Lovely, that's what I'm talking about. Let's go. Amazing. So, okay. Though I noticed it does take indeed a lot of time to actually start up. I wonder how we could improve that, possibly. But anyways, so what else right now? Shader. Add a second argument, blah blah blah. This works. But I don't need the color in the vertex shader. I want it in the fragment shader. Can I do FN? Nope, the vertex attributes are only attributed. Yeah, that was a question of mine when it comes to WGSL, because I do remember that there's some other languages that maybe allow that. But anyways, so basically kind of like just automate for you that process of, but anyways, this is where the structure-based approach becomes handy. A structure with fields labeled with built-ins. Okay, so we have already done this before. So it's basically vertex output. There you go. We have already done that. Nice. Built-in position. Does not refer to a vertex attribute. It can also refer to another field. Okay, so as you can see, color. But hold on. The location here does not refer to a vertex attribute. Oh, I see. I see what they're talking about. So forward to the fragment shader. So this is how we actually forward stuff. So out.color, in.color, makes sense. And then here we could take the vertex attribute in the fragment shader and essentially pass it in. Okay, let's try it out. Oh yeah, I think why I didn't, like last time we have tried to make the colors work, like multiple attributes, but didn't work. I think we probably have missed this location here. That's probably what we have missed before. So yeah, right now let's actually add a color attribute. Let's try to do it on our own. And let's see. So for the color, I'm gonna go with Vic3. Yeah, okay, fine. Vic3 color. Let's go. So, and then what I could do, I could add it here. There you go. And I'm just gonna copy this to all my vertices. Though I'd like if I add a trailing comma, it would format it better, I think. There you go. Nice. Let's go. Let's add the trailing. Well, hold on a second. Go back. Let's add this, this, and then let's add a trailing comma so we can format it well. And there you go. Nice. Nice, nice, nice. So this is the first triangle, that's the second triangle. Let's go. Very cool. So now what we're gonna do, let's see. So okay, so right now it's all red. Let's change it a bit. 0, 1, green basically. Here let's say blue, and basically let's say similar thing here, red, green, and blue. Colors could be very useful for debugging to see which vertex is which. So that's nice. Okay, so we have added the color here to our vertices. Next up, we should probably change the layout, I think. We gotta add a new layout maybe or something. Not here though. Yeah, no, not this one. But yeah, this one. Okay, the vertex attribute. Let's go. So for this, we're gonna basically add another one, I think. And what's happening here? Excess elements. Oh, let's say 2 here. And the format, let's say it's float 3. It's a Vic3. So offset 0. And here, actually, we're not gonna say offset 0. We're gonna say size of GLM Vic2. Basically, because this is what the previous one is, so we gotta offset a bit. And then the shader location, well, 0 is already being used for the vertex position, so let's go with 1. And yeah, I think that's probably all we need to add a new vertex attribute there. Next up, let's see what we gotta change. Maybe that's it, possibly. Let's see. Yeah, I think maybe that's it. Oh, by the way, we didn't change the fragments though. And also we haven't passed it to the fragments in the first place, right? We have just changed this. So, sorry, well, we haven't changed the shader at all yet. Okay, let's change it. So the vertex output, we're gonna, well, In fact, before the vertex output, let's change the vertex input first. So location 1, because we're getting the color in location 1. Because pretty much the name itself doesn't matter. That only matters in the shader itself, but like you could call your name whatever you want. What matters is the location. So color, we just have a vector 3, and what's next? Okay, great. Now we're just gonna say, well, let's add it to the vertex output 2. We're gonna say location 0 color vec3f. Okay, so this is the locations of these are different than the location of these, but anyways. And then here I could hopefully say, oh, actually I'm gonna call this out instead of results, because result doesn't make any sense here. And let's just say out out.color is equal to in.color, so we could actually give it to the fragment shader. Then here the fragment shader is taking this vertex output, so we could actually get it. So here we could just say now vertex, hopefully dot color. Oopsies. Vertex dot color, right? Yeah. Let's go and, or actually maybe let's say in. What they call it? Yeah, they call it in. So I'd like to stick with their conventions as much as possible. So let's go with end up color, although it doesn't really matter. But anyways, let's see. Let's see if this works. Okay, there you go. So we got color triangles now. Nice. Lovely. So this is the first vertex, this is the second, this is the third, because I know that I have set it for every first vertex. I set it to red basically. That's why we use like colors for debugging, for example. Though you could see that it's kind of weird. The colors are very weird because probably you gotta handle sRGB. We're probably not handling that yet. So, but anyways, so what's next? You could set the requirement limits, though that's not really required, but anyways. Vertex data, as you can see, it becomes very weird and hard to maintain. Though one thing that I'd like to improve this design, so whenever I don't like when I want to change some attribute or add some new attribute, I don't have to go crazy with changing a lot of stuff. What we could do, we could automate some stuff, hopefully. Let's see. For example, one thing that I've noticed is mapping, let's see, the format of WGSL. Well, the format of, yeah, the vertex format. So what we could do, we could probably create like a function that would map something to the WGPU vertex format, I think. Or let's see, so, and also this vertex attributes could probably be gotten from the vertex itself. Let's see, vertex attribute. In fact, this could probably be global for now. And is it? Yeah, at least this one. What about these ones? Vertex buffer layouts. Yeah, this one too. These ones, of course, probably not. Actually, they could, but, well, I don't know. But anyway, it's fine for now. Fine. We're going to do that later. So what's next? Interleaved attributes. Okay, they're just doing the... oh, what's happening here? Race tried. Yeah, they just changed that. We haven't needed to change it because we have a vertex struct, which automatically does the job. Max buffer size, oh, that's just the limits. Okay, shader location, great. Non-null offset. Oh, by the way, the offset, we could probably automate that, in fact, maybe. So like offset, what we could do, I'm not sure if there's like a C++ function for it. Doesn't seem so. Or is it? Doesn't seem so, but in C at least you can do it like this: offset of vertex color, and then it would just do the job for you. We could just do something similar here just for the sake of being consistent. And yeah, let's go. Come on. Nice, lovely. Righty, size of vertex. Size, step mode, attribute count, attributes. Could probably put these there right near the vertex itself. Yeah. So there you go, const expr for now. Const expr std array. This should work just fine, because there's nothing very like, this is like static, not gonna change, so it's fine. Though we could probably put like a vertex class and stuff like that, but anyways, which contains all of these stuff. Anyways, let's go to the next step. What's next? Multiple buffers. Yeah, we have already created multiple buffers. Oh, hold on, what he's doing here? Is he creating a second buffer for the colors? No. Bro, no way. This time the maximum buffers tried can be... Why he's creating multiple buffers? Oh, it's option B. Okay. Oh, he's just showing the other option. Okay. But I wouldn't really go with multiple buffers for this, honestly. Well, depends actually. Yeah, depends. The nice thing would be about multiple buffers is like, yeah, the nice thing would be about, I see, about cache. Cache coherent? No. Cache locality, yeah. So basically, at least in mobile, for example, although WGPU Dawn implementation doesn't support Android just yet, but it's in the works. But basically in tile GPUs in general, you probably would like to have multiple buffers, one only for the position, and then another buffer where you have the other attributes interleaved for best performance, at least in those GPUs. So yeah, that's something to consider, I guess. That would be interesting to try out. Yeah. So the stride is the same for max attributes, so it's not a problem. Okay, what is about option B? But it didn't say like what is the what is the trade-offs between the two and stuff, I think. Or maybe I missed it, but anyways. And yeah, you set both the vertex buffers. Interesting, lovely. Yeah, probably gonna do this honestly. Anyways, conclusion. Triangles with the color attribute, same result for both options. Yep, change the background. Okay, let's actually try that out, honestly. Why not? So how are we gonna do this? Vertex attributes. So we're gonna have, you know what, let's just go to the next one. Anyway, let's not waste time. We have already created an index buffer. Let's go. Buffer creation and render path, set index buffer, as you can see. Nice. It would also be interesting to try to put everything, like even the index data, in the same buffer and try that out and see if it works. But yeah, all the basic, though you could probably run into some alignment problems. Not sure about that. And also you'll have to include two usage flags for the same buffer, like the index and the vertex, which could affect performance negatively. But on the flip side, you just have one buffer and then you just do one copy of, actually not one. You still need two, I think. I don't know. But they could be parallel, but that could be the same. Well, anyway, never mind. Using index buffer is rather simple concept. Save a lot of VRAM. Anyways, load in from file. This is the occasion to introduce some basic resource management. Usually people use like some folder called assets, though I've seen resources before. But yeah, for us, we have already done that. We have made an assets folder with shaders in here. So nice indices. Okay, so he's kind of like creating a little of his own, you know, OBJ format kind of. That's interesting. Great. Lines that are empty or starting with are ignored. Oh, for comments, I see. So he's basically creating a little custom format for tutorial purpose. Anyways, I guess I'm not going to detail the parser. Okay, yeah, it should be pretty simple. There we go. Though he's using, yeah, seems like he's using C style kind of stuff. Maybe? Not sure though. Actually, not really. Where is get line? I don't know. Let's see. Anyways. Okay, that's pretty simple, but we're not gonna do that. There's a lot of formats out there already, but it could be useful for custom formats for your game if your game is pretty unique. Maybe something like Minecraft, possibly, or like some voxel game or something. Anyways. But probably most of the time, just go with formats like GLTF or even OBJ if you really don't need anything special. You can replace the definition to point data and index data vectors by a call to our new Lloyd geometry function. And the point data and index data, yeah, I see. I see. Use an absolute path. Okay, this is what we'll do. Use the command line argument to tell. This is what I'm using actually. Kind of. I'm just setting it, in my case, in here I have in my options. I'm just saying that the working directory, I'm setting it to the root of my project, and that works for me. So option E, automatically copy the resource in the directory from which your ID. That's also possible with CMake anyways. But I'm interested into how he's gonna do it. We'll do something like this, resource there. Oh, I see what he's gonna do here. Interesting. And then yeah, CMake current source there. Well, honestly, I think I'm gonna use this because otherwise, if I don't use this kind of setup, then if someone, like if I publish this into GitHub, probably not a lot of people would know how to create like a working directory and stuff, or they wouldn't notice, because this is like just in my IDE, not really. Yeah, that's pretty interesting. So we're gonna remove this because you see, if someone just clone my project, let's say, and run it, yeah, nothing would happen. There you go. No triangle, nothing. Because it couldn't load the shader. I really don't know why it's not giving me any stupid errors. I really don't know why. Like, bro, come on. Hold on. Let me check the file. So path, file, path, code. Yeah, I guess I'm not chicken for this, isn't it? Let's see if this would work. Like, I haven't seen any error at all. There you go. Okay, nice. So right now it's actually erroring, and yeah, there you go. So failed to open a shader file. Okay. So let's go and use his way, and I like this method. I always struggled with such a thing, so that's a very cool method of doing it. I'll give it that. We will do something like this. Will be added by CMake. Okay, so we're just gonna use target compile definition and use CMake to hardcode the absolute path. CMake current source there / resources. Yeah, that's very cool. So let's go with that, honestly. How are we gonna do this? Let's put this here, for example, though honestly this is kind of weird. Let's put the executable in fact here after the dependencies, and let's put these guys together here. Yeah, and basically target compile definitions, and I'm gonna use the project name. So if I want to easily change the name of my project, I can. And resource there, private, CMake current source there / resources. Pretty cool. So now CMake should expose to us this resource there macro in our code that we could use. Can now specify target compile options for target, which is not built by this project. Oh, my bad. So let's actually copy these two here. And yeah, great. Now let's just copy the name of this and let's go to our project. First of all, let's reconfigure CMake. So we could then do that, hopefully. Cannot get compiler information, what? Why? Macro names must be identifiers, huh? Interesting. So is this like the real problem here or what? Let's see. Yeah, there are the actual problem. So, well, maybe not. Hold on, let's see. Let's reload CMake. And let's see what's up. Yeah, there it is the actual problem. Let's see why. So it basically said for some reason that resource there is not somehow correct or something. Weird. Let me research about target compile definitions. I don't know what's up with search Brave. There you go. And you actually do it like this. I don't know if this is, or may optionally have values. Or you could, seems like you could do this. Public foo equal 1. Treat dash dfoo is equivalent to dfoo equal 1. Let's try this one. Let's see, make sure we're doing that. So target compile definition is private, resource there. Oh, there's a space here. I'm not sure if I'm the one who added it. Oh, it's kind of like being added automatically. Could it be the problem here? Maybe. I don't know now how to save this without actually formatting. But I'd like to try this for a second. I'm just gonna disable auto format for a second and just see if that's the real problem here there. Okay. And let's see if that would fix it. Yeah. Formatting is messing up with my thing. It added a space there which broke it. Interesting. So yeah, so what I'm gonna do, I'm gonna keep reformat code, but I think I'll try to remove CMake for a second. Let's see. CMake, though there could be some way to actually like just disable it for a specific line, but I never used it, so I don't know. So now if I actually change something, let's see if it would auto format. Yeah, it doesn't. Okay, great. Let's see. Of course it would still fail right now because we're still not using this macro that we have exposed from CMake. So that's what we're gonna do. As you can see, it still doesn't work. So okay, great. Let's go now to the file stuff, the path stuff or whatever. Yeah, there you go. Current path. Now instead of this current path, I think we could probably safely say resource there macro, right? I think so. So path, shader, assets, and let's see. Hold on a second. What I'm doing? No. Yeah, that wouldn't work actually. Hold on. Let's go back to CMake. What is happening here? Yeah, not slash resources. We're gonna go with slash assets. And I'm honestly gonna call this assets there. Assets directory. Oopsies. Yeah, let's go. And this should work on everyone in the machine. Kareem Hamdallah, welcome to the live stream. Hello. Okay. Let's see. So we got assets directory. I'm gonna reload CMake, and we can come here to this, and we could put it here. And now we don't need this assets. I could just say shaders triangle WGSL, and yeah, now this should work. Hopefully, when we're gonna publish this into GitHub, everyone would just need to clone the project, run CMake, and it would just work. They don't have to worry about some sort of path and assets and crazy stuff like that. This is a very, very good solution. I never really seen someone do it before. Thank you for Vulkan tutorial. Amazing, bro. You're welcome, bro. Anytime. Thank you for the great words. Okay, so let's see. So right now we got that sorted out, which is amazing. I love this. I've learned something new in CMake now. So that's nice. Well, not really CMake related, but like just how to do such a thing, how to fix such a problem of resource path resolution. So yeah, nice, amazing. That defines the function. Current list there. Anyway, portability. Hey, but in the end, our executable uses an absolute path, so you have this portability issue in trying to share, right? Yes, indeed, but we can also add an option to globally change the resource directory and build in a release that we want to be able to distribute. Option dev mode. If dev mode from the resource tree, so that when we dynamically edit resource, like, oh, okay, I see. Interesting. So now that we have it as absolute path, it's a problem, big problem, right? I wonder how can I learn advanced OpenGL stuff like PBR shading, image-based lighting, shadow mapping, but PCS filtering with shadow to cascades, light mapping, path tracing, and probes, global illumination. How graphics engineers learn these stuff. I'm not a graphics engineer, so I'm not sure how to do it, but there is a great tutorial for OpenGL though. That you could learn these stuff in, or at least some of these stuff. Well, what's happening with Brave? No idea. What is it called? Yeah, OpenGL tutorial. Though I honestly always would like to read through this tutorial, but I never get the time to. But anyways, if you go to probably advanced lighting. Yeah, there's some cool concepts right here. There's gamma correction, there's shadows, normal mapping, point shadows, parallax mapping, HDR, bloom, deferred shader, and even SSAO. There's also PBR stuff. There's theory, and then there's lighting. This is a very interesting tutorial that could give you the points across real quick. Hopefully I didn't read it all before, but I'd like to do at some point. So yeah, there's even text rendering here. 2D game breakout. There's some 2D games here. Post-processing, nice. And some guest articles. Skeletal animation, let's go. OIT. CSM, what's that? Cascaded shadow map, let's go. That's what you're looking for. And then there's OIT, what's that? OIT. Order independent transparency. Oh, that's interesting. What else? There is scene graph, nice. Oh my god, I didn't see this. DSA, direct stage access, and compute shaders, physics-based bloom, area lights. Okay, that's pretty cool. Unfortunately, I read all of these books, but I'm talking about a little bit more advanced stuff. Probably would go for books there. I don't think. Yeah, probably books is your best bet for that. For very more advanced stuff than this. It's just start point, not fully performance systems. Yeah, I'm probably gonna find these in books. I do remember some book called, let's see if I can find it. Oh my god, this is super. Let's go Amazon books. You don't of course have to do it in Amazon, it's just great to search. And let's look for rendering, and well, I have no idea what these books are for. 3D rendering. Great. This is a cookbook, not really for advanced stuff. Okay. I can't really find the book that I was checking out. Let's see. Alright, hold on. Let me see my phone, because I don't read books on my computer mostly. Let's see if I can find it. What is it called? Yeah, let's go. Hold on. Yeah, it's called real-time rendering. Real-time rendering. Let's see if I can find it here. Yeah, this one. This one pretty much goes in a lot of details about all techniques, basically. It's pretty interesting. Well, not all, but you got the point. They told me that to read papers and implement from it. Oh my god, they think I'm researching NVIDIA. Yeah, that's probably the middle ground between reading actual papers and tutorials like OpenGL tutorial. So this could be useful for you. I'm not sure, but this could be useful. It covers a lot of rendering techniques, so real-time rendering to be exact. So yeah, all right, let's go back though. This is very interesting, honestly. I have to read it at some point. Let's go. Real-time rendering, just give theory and math, not implementation book. No, not implementation, of course not. But it's okay, Mail. If you want implementation, maybe you may find something in the cookbooks. Like those books that called cookbooks are the ones that actually show you implementations. So maybe like OpenGL cookbook, I guess. Let's see, Amazon books, blah blah. Let's see, maybe OpenGL cookbook could help with that. I'm not sure if it does contain the stuff that you want, but maybe. OpenGL development cookbook. The one that I've seen is probably this one, though I don't remember honestly. Yeah. Yeah, probably this one, but I'm not sure. But yeah, look for a cookbook. That's the one that you're gonna find implementations in, basically. But yeah, pretty much. Hopefully that helps. Rich. Yeah, that one about shaders. Yeah, just look for some cookbook for OpenGL or Vulkan or whatever. So yeah, I think it may have advanced stuff. Yep, pretty much. And it would have implementation. Most other books would just have like mostly theory and platform, like API agnostic information for rendering. So learn OpenGL, teaches OpenGL, not so much computer graphics. Yeah, pretty much. But it does give you like starting point to the rendering techniques, basically. So, okay, portability. All right, let's actually include this. We add an option to enable different settings when developing the app and when distributing it. That's very, very useful. Oh my God. Target compile definition, and if that's the case, you're gonna say /. Yeah, that is amazing. Oh my God. I always ask myself how to do this correctly, but there you go. Learned something new. So let's see, target. So we got dev mode, target compile definitions. Well, here we got assets there, well, directory, and assets directory. So you don't have passion towards graphics. Not really. Like, I actually just started in graphics programming. It's not that the question that if I have passion or not. I'm just starting, basically. As far as path tracing, there is a good videos on YouTube, because pretty much most of my videos are just me learning something new and in real time, and actually showing other people, or sharing, basically. Or sometimes just learning something new offline and then just kind of showing up what I was up to. And most of the stuff are like you can't really find out there. So yeah, for example, WebGPU Dawn, if you search for a tutorial on YouTube, you wouldn't find that, at least currently. So yeah, in release mode, we just, well, this is not really like a actual tutorial, but like just me following up with the tutorial, and like you can see how I do it myself. So yeah, let's go. In release mode, you just load resource relatively to, anyways. So that's pretty much it. So if div mode, assets directory, /assets here, /assets here, cmake current source there. Yeah, this should work now. Nice. So basically, when you want to ship your application, you would ship it with the executable and the assets folder in the same directory, as you can see. But while we are in development mode, the actual binary would be generated in a build directory here, which is not what you want. So we just basically do this. We use absolute path for it, basically. So that's a very, very interesting way of solving that problem. I love it, absolutely love it. So let's go. So this should work just as before, but now, oh, hello. Who's connected now? Let's see. Oh yeah, there you go. DE0.
You're
Welcome.
muted in Disc, but I could hear you.
Yeah, I muted in Discord so you can basically hear me in the stream itself, essentially. But people can actually hear you in the stream. Desktop audio. Though
Did you get the triangle colors working?
Can you hear me in
Yes.
Discord now?
Yep.
All right, great. Let me make sure that the stream is fine with that. Yeah, seems to be fine. Sorry, what you said?
Did you get the WebGPU triangle color, the Vertex colors working?
Yeah, I got it working. Last question. Let you code. Where are you from? I'm from Morocco. So yeah, this should be working now. Let's see. Cannot specify compile definition for target app. Oh yeah, project name. That's why even in tutorials you should be using project name instead. Oh, nice. I'm from Egypt. Well, welcome. You're welcome. Egypt. Welcome, welcome. Let's go. All right.
Did you know I'm the blank guy on YouTube?
Sorry, what you said?
Did you know that I'm the blank guy on YouTube?
Blaine? What?
Like the one with no name.
Oh, no, I didn't know.
I don't know how
Let's
that
go.
worked. It's some glitch on YouTube's end.
Oh, so you don't have a actual name like that? Like,
No, I didn't set that. I've had this account for about 11 years, but
but why it doesn't show any name?
I don't know.
Weird.
I just now created a channel this year,
That's
and
interesting.
so I don't know if there was some glitch, but yeah, it just never gave me a name, even though
Yeah.
I
Though,
checked.
can you hear the his voice in stream? Just let me know. Can you hear your own voice in stream? Hello?
Yeah, I had to mute it, but when I muted it, I could hear myself. Yeah.
All right, great. Okay, so we pretty much got to this point. We have set up vertex buffer, index buffer, at least from the previous stream, and we have added color attribute basically. So yeah, that's nice. So yeah, we got it working now, and right now we have this variable that we can toggle from CMake. So you could see -d dev mode equal off if we want to ship the application. So we want to ship the application, we could just get the executable with whatever libraries, dynamic libraries if there's any, and also we get the assets folder with it. You're welcome to join voice chat if you join this Discord. Yeah, basically, everyone is welcome to join Discord, so you could actually join the live. So yeah, let's go. Okay, so this is something new. I never seen any YouTuber done this before. Link invalid. Oh my god. Let's see. Let me try to invite. Invite link. Never generate new link. Copy. Though you may need to actually get the member role to join, but I'm not sure. Maybe I have actually disabled that, but let's go. This is the link to join in. And honestly, let me also update the description so it gives the correct link. I wonder how much people have tried to join my Discord that wasn't able to, because I haven't changed that link in ages. But anyways, though someone have said that to me back in this like some time ago in the comments, but I kind of forgot to actually change that. So yeah, let me know if that works, if that link works, and then you could basically join the channel, the voice channel. Anyways, so what's next now? Amazing.
I think the link actually worked. He just had a problem. He had a mistake with it or something.
Yeah, maybe like for example, you need to have like a verified phone number and a verified
That's what I
Gmail, I
think.
think, or something like that. But yeah, there you go. He have joined. Welcome to the Discord server. Try to join the chat now if you want to.
Gotta agree to the announcement, right?
Yeah, you
Agree to the
could go to
rules.
the rules channel. Yeah, rules channel. You could just emote on that one, and yeah. Anyways, let's get further with this. The CMake build option is built-in option CMake that is commonly used. Set it to debug to compiler program, debugging symbols, set it to release fast. But this is bad. This is bad. You still want to be able to like test your release mode. So I have actually thought about this one, like to use CMake build type instead of a custom variable called dev mode. But that's bad because even while you're actually developing your application, you still wanna like try to the release CMake profile even in development. So for example, let me try to add release and even actually find out if it works. Actually, it's gonna take some time to build though. So that's something, hopefully nothing wrong. Sometimes the release doesn't work. Let's see. CMake build release. Let me change the build directory to release. Though if you don't have my IDE, your IDE probably have something similar. Otherwise, you could be just using the command line, just setting the build directory to, yeah, basically. Anyways, so build / release. Let's actually try the release mode just to make sure. Okay, so right now it's going to reload for release, though it's going to take some time though. Because it's build. And it's also the fact that it's release. So, well, anyways, load in CMake project. That's gonna take some time. Yeah, it's gonna do the whole process again, but for release. Okay, while it's doing that, let's actually go ahead and look at the tutorial what it's doing. Great, I strongly suggest we use Solid or shader code. Yeah, I agree. Very much agree. Never seen someone do it like that. Pretty cool. Not file is open. SIGG shader source, SIGG. Yeah, it's using the C style. GitHub Copilot have gave us a nice C++ style of doing it, I think, which was, hold on. File, there you go. So you do it like this, path, ifstream, and then you do this weird thing, ifstream iterator. Yeah, basically. So he creates a string out of an iterator, and in this case you get the iterator from the file, and this is just like the end, and the end is probably like this eof iterator kind of thing, but yeah, that's basically how it works. Okay, what's next? Let's see. Okay, no longer need to rebuild the application when you only want to change the shader. Great. We've been already doing that from the start. Yeah, transform. Right now we just made it more robust, so when someone else tries our project, it would be pretty cool. Anyways, if you run the program now, you should get something like this. Ooh, what? Oh, did he just change something? Like the, I guess the vertices or something? Oh, yeah, I see. he done this. Okay, I see. Makes sense. So let's actually do it ourselves. Though this is gonna take some time to actually encode here. Though I'd like to actually get, like, let's say OBJ working or something. What do you guys think? Lloyd shader. Our loaded shape is a bit off. We should move it to a better center rate. So I do move them objects, similar to how I fixed the ratio issue in the previous chapter. Oh, what? When did he fix that? I didn't see it. I can do it in the Vertex shader by adding something to the X and Y coordinates. Yeah, I know what he's doing here. We could just use a transform for that because we have GLM. It is important to apply the scene transform before the viewport transform. The ratio, we'll get back on this more in detail when adding the 3D to 2D projection transform. There you go. Great. Okay, color issue. All right, so this is what I was talking about. Probably gonna cover sRGB now. Yeah, seems lighter and even have different tints. Correct colors.
They use MS Paint to check the color.
I have just realized. Interesting. Does not match. Our problem here comes from the swap chain format. Man, I found in this tutorial you follow some advanced stuff I'm trying to do with lighting section. Which tutorial? That's nice. You follow some advanced stuff with lighting. We haven't done lighting yet though. Yeah. Alright, so what is happening here? This guide you read now. Oh yeah, there is actually some advanced stuff, right? There's specularity, normal mapping, image-based lighting, cube. I'm very excited for the other stuff, for the other advanced stuff. I love it. So we'll see. We'll go through it all, hopefully. Well, oh, it does not match what's happening. Mean that we are expressing colors. Blah blah. I'm trying to not read everything, otherwise this would be too long. Though I'll probably read it offline or off camera. Right now, just trying to make things work, pretty much, mostly. It also has ray tracing, but in to-do list. Well, ray tracing, I don't think the WGPU supports that yet. I mean, the spec maybe support it, but the implementations maybe not yet. Though I'm not sure about Dawn. Like, at least for WGPU, the Rust or Firefox implementation, they haven't done yet, though they're very, like, soon they will actually support it. They're working on it. They're very close to finish it, or at least get some working version. But, well, maybe Dawn, since it's more advanced than WGPU, maybe they have already figured that out. I don't know. He learned vector math basics, dot product, cross product, etc. Yeah, that's nice. Okay, let's see. Alright, to avoid these, need to manually handle enum values. Magic enum. Oh, I see. To do reflection. Great. I see. But it's very clunky. This library just like goes ahead through all the values, which you can see how it can affect compilation time. I just like kind of, well, basically in C++ we don't have any kind of reflection. So this library is just like going ahead and what is the name or is the term? Like when you try all combinations, basically, I forgot the term. Because you need to know the math first, and once you do, things will make sense. Yeah, you don't really need to know all the math. You just need to know like how to use a transform, like what happens, like basically to how to solve some problem. Like you just treat it as a tool, but not the actual calculations themselves. Though that could be useful in optimizing that stuff further. But yeah, like for example, you only need to know, let's say, what happens to when you, let's say, multiply a transform with another transform. Let's say when you multiply a transform with a vector. But surely it helps to know the nitty-gritty details mathematically. But anyways, the BGRA part means that colors are encoded with the blue channel first, then the green one. And by the way, you could actually just talk by I don't have to type in there. Maybe 1 year worth.
Yeah, kind of talk to him as well, though.
Yeah, I mean, he hears you. He hears you. So yeah, I forgot that. It's a pretty small amount of math. Maybe 1 year. I already have these features on my engine, bro, but I need to see example to get my systems work more correctly and optimize it. Yeah, makes sense. He basically wants some more advanced tutorials. So the 8 means that each channel is encoded using 8 bits. Though you should probably find a lot of advanced tutorials out there. The problem is the mid-level tutorials, like between beginner and advanced. That's where you don't usually find a lot of resources. So UNorm sRGB. Okay, these are the format that we're using. In fact, it's the only format I think supported by what is it called? By Dawn, basic WGPU Dawn or WebGPU Dawn. So yeah, I'm gonna go through this later, honestly.
Like the way I'm thinking about it is that once you learn the math, these things like lighting and path tracing, they'll just click because you know the math that makes it work, and so it should just click.
Yeah,
that's what I'm getting at here.
But like not learn it like how they teach it in school. Like you don't really need all that details.
Yeah, least. You don't need to.
Like for example, the computer does all the calculations. You just have like they're a tool. You don't need to know how to construct
Yeah,
it.
exactly. You just need to
Though,
know
yeah,
the
you just need to know how
yep.
to use them, basically, and when to use them.
Yes,
Though
exactly.
it would be nice if you know all the details to, let's say, optimize, for example. But yeah, most of the other stuff, calculations, etc., that you learn in school is done by a library like GLM
Like
and by the
we
computer
like
itself.
GLSL itself has all
Yeah,
these functions
also,
built in.
basically.
But like the thing is, you need to know what they do and like how to apply them. That and then everything just clicks
Yeah,
with
basically
lighting and
that's
stuff
essentially
like
it.
that.
Though I had a problem with school, honestly. They don't like teach stuff in the intuitive way. I usually go like I learned a
Yeah,
lot of math just by trying to write shaders and trying to understand shaders.
I think I
Just
got pretty lucky with my math classes in school, but all the other classes I hated.
yeah, it's like a lot of the math, like the advanced math that I've learned, of course, other than let's say high school. Uh, well, not high school, but well, anyway, most of the advanced math that I know of, I have learned it with programming, because of game dev, and because of what it is. Yeah, shaders, basically. Especially graphics programming. I learned most of the math from graphics programming because here you could just tweak values and see in real time what is happening. So it's very, very nice. Linear, color, POW. So is the force non-sRGB texture format. We don't have this option actually in Dawn, I think. But our option right now is probably this. Yeah. Great. We apply gamma correction to the color. We need to convert our input sRGB color into linear before the target service converts it back to the sRGB. Gotcha. Let linear color. Hold on, what? We need to convert our input sRGB color into linear before the target service converts it back. Okay, let's actually try this out. What I think about friend cell effect, the node in Unity shaders have the same code of node of Unreal. The same my engine and in example use this, but the point is how to build well architecture rendered. You know, architecture and project structure, there is very, very little tutorials and resources about that. You just have to learn it the hard way most of the time. But yeah, you could probably find some gems out there. I haven't found much gems. So, well, let linear color. Like, especially in C++, like, bruh, it took a lot to even start getting something working. Especially when you start using OOP and crazy stuff like that, bruh. Anyways, so linear color. Anyways, let's try this, what it's gonna do. What is it? Triangle, WGSL. Okay, let's try this actually first and see the colors. There you go. This is the colors that we have now, and let's try this. It surely looks out of
ECS will
place.
solve all the pain.
That's complex and is not for every project though. But yeah, it depends. Like for example, a physics engine, surely ECS. Oh my god. But yeah, depends, really depends. Like if you have a lot of entities, surely ECS. But anyways, so linear color. But yeah. But basically like having like individual objects like in OOP, it's kind of simple because you have everything encapsulated. But ECS is another kind of pain unless if you have some good abstraction or library like Bevy ECS. Otherwise, you would be just juggling around all sorts of arrays and anyways. Though Zig also have a great feature for that using metaprogramming. It's very, very interesting. Querying data from DOD is faster than OOP. Not really. Well, depends. But like if you're actually querying data in bulk or like processing data, especially processing data in bulk, yeah. But anyway, let's see, depends. It really depends on how you do stuff. Like if you have one object and you basically access all the object's attributes at once, then well, probably OOP. But if you know, let's say that you have these objects and you want to access all of these positions, which you will in a physics engine, then surely you want all the positions lined up, or maybe even all the components lined up individually, like X array, Y array, Z array. But it really depends on your use case, basically. Yeah, it depends. That's what's the problem with ECS. It really depends on your own projects and how you want to structure it, really. It's not like a size fits all, but yeah. Anyways, so we got the linear color here. Pow in the color. Great. Vic3F. Though, does he do this in the vertex or the fragment? That is my question here. Fragment shader. Will handle the color space conversion. Yeah, he's doing it in the fragment shader. Okay. So not the vertex. So let's go ahead and do this, and then I could guess, yeah, it would return that. Let's see if this would make any difference there. This is what we want or not. Oh no, that looks super dark.
What the?
Yeah, probably not what we want. It's probably talking about, like, I guess when you're using sRGB, maybe? I don't know really. To convert our input sRGB color into linear. Weird. But maybe, or maybe this is like for sRGB colors, which you usually get from images. But anyway, it's fine for now. It's fine. Okay, fine. So let's just leave it as this for now. But
Dude, it
probably
makes me smile so hard when I see them using MS Paint.
Oh, it's called gamma correction or tone mapping. Tone mapping, interesting. Anyway, we'll get this back. We'll get this into this when we get into textures. Probably that's probably where we're gonna need that actually. Anyways, first uniform. Okay, look at that. If we look at our current shader, we see some hard-coded constants. Oh, he's doing this ratio before, but I don't know when he have done that. It's crazy.
Aspect ratio?
Yeah, we have talked about that before. Similarly to how I fixed the ratio issue in the previous chapter. But I haven't seen that in the previous chapter. Is it here maybe? Oh, there you go. There you go, okay. So I have missed it. I wonder how much things I missed. Ratio correction. Okay. Though, yeah, this we don't need to do this, but that's probably just for the tutorial's sake. So yeah, we're gonna have an actual transform camera, like orthographic or perspective, which would actually take care of this ratio for us.
And you pass that in as a uniform?
Yeah, basically you pass the whole transform, perspective, and view, basically view transform, and it would take care of the ratio. So yeah. Yeah, there you go. Thanks to uniforms, he's probably talking about that. Okay, let's go to shader uniforms now. A first uniform. And rebuild a new shader module. Okay, so basically there's two options when it comes to changing values in the shader. There is uniforms or actually rebuilding the whole shader. So of course rebuilding the whole pipeline is well, depends on your use case, but it's usually not the correct thing to do. It's usually just use but they're called specialization constants, at least in Vulkan, though I'm not sure. There's probably some way to do it in WGPU too. Yeah. And there's also actually there's another option other than uniforms. There is push constants, at least in Vulkan, though I've seen something similar here. If we go to, let's see, let's try to pass time actually ourselves, and let's see if we can figure it out. But basically I've seen, I guess in layout or something, I don't remember. Let's
What the heck is a
see.
push constant? Why? How does that help?
Yeah, it basically kind of like a, you use it essentially to pass attributes that you want to pass every single frame. But it's very small though. It's very small.
So I'm assuming this gives a performance benefit, like a small
Yeah,
performance benefit.
yeah. Well, it
Okay.
depends, of course, on the hardware.
Yeah.
So yeah, there is this constant. So I would guess this maps to Vulkan, push constants, right? But let's try this out. So we gonna
Also,
need
have you heard of
constant entry. What is it?
shader storage buffer objects? Like, what's the difference between that and uniform
Uniforms.
buffers?
Uniform
Yeah.
is kind of like, uniform buffers are read only, but also they have some alignment stuff, and also the fact that they're limited in their size. Like you can't go over some size limit, and you can't write to it from a, let's say, compute shader. For a storage buffer, they're far more flexible, though I guess maybe a little more efficient in some cases.
But
So
you could also make them read only though, right? The shader
yeah, there
storage.
is a read-only storage buffer.
Mm.
But yeah, it depends pretty much. But like if you want a really big buffer, let's say, and you want to, let's say, to write to it from a, let's say, compute shader, then you would go with the storage buffer for sure. But yeah, there is some nuances on which one to use. Which
At the end of the day, all it is GPU memory. It has like 10 different terms, 10 different ways to
well,
access.
GPU memory,
But yeah.
but different constraints essentially, and different
But
mappings
they're
to the
pretty
hardware
arbitrary.
possibly.
Like the hardware has nothing to do with this.
It does have possibly. I don't know. Like the thing is about the APIs, that's kind of like just trying to, I don't know, really. It's weird.
Like, yeah.
It's weird. But you could probably survive with only storage buffers, possibly. Not sure.
That's probably why they did the push constants, is because the uniforms and the shader storage buffers didn't really align very well with how it was working.
Well, the thing is, push constants, you can't use it for everything. It's very small. And I think on Android and mobile devices, it's just simulated. So it actually end up hurting performance, I believe. At least that's what I remember from my research, but who knows. So let's see here, constants auto. Well, not auto. Well, I'm gonna go with WGPU constant entry.
You know, just wait for the day for the GPU manufacturers to make their own graphics APIs.
Well, Nvidia already have CUDA, kind of, but
Yeah, they have
it's,
CUDA, but that's not a graphics, right?
yeah,
So.
yeah. Well, like AMD have actually created Mental, but now it became Vulkan, which is cross-platform.
Right. Yeah.
Apple, same thing. They have created Metal. So
Mantle. Metal. Yeah, I kind of got them confused for a bit. Mantle, metal,
yeah,
until they renamed to
they have
Vulkan.
something to do with metal. Vulkan.
Yeah, because literally mantle is literally molten metal
Yeah,
in the earth.
that's crazy. Stencil state. What GitHub Copilot I've generated here?
Let's make a new graphics API called Molten. Oh wait, there's already Molten 2K.
Yeah. WGPU constant entry. Let's go. Or actually, should we use an array or a struct? Probably a struct would be better though later on. But for now, let's keep it simple. Let's go with an array. Though a lot of things could be better.
It kind of sucks that these things are just APIs, because it used to be that OpenGL used to work like the hardware worked. Like you call it GL Lite, and that literally changes the lights on the GPU.
Oh well, but like people wanted more control over the actual hardware. Like basically everything was like baked in into the hardware, so you couldn't really change much about it, how it works. But it was performance, kind of. Yeah. At some point, you were just poking memory, you know, the graphics memory directly from the CPU, like from assembly.
Oh, really?
Yeah.
GL Vertex would actually talk to the GPU and put a vertex in.
Well, not vertices, I think. It was just like bitmaps, and you would just poke the pixels directly. Like, actually, no. You would have like sprites. So instead of having sprites in an actual engine, it's like, for example, in consoles, you would have like an actual sprites. Like, maybe you would poke some memory here and stuff in this particular address, and then it would create a sprite of this or whatever, stuff like that. It was basically, instead of having an engine, you would just use assembly directly. Everything's baked in. Well, you have little control to how everything works. So if you don't like what they give you, you're screwed. So yeah. Double value constant entry. What's up with this? This is stupid. What? What does this have to do with anything? Why there is a string in the key? Bro, what? I would guess that's maybe the name of the constant, which doesn't look super performant. What? That is crazy. But yeah, let's try to make this work, I guess.
Chain struct.
Key. I would guess the key is probably like the actual, the actual name of the variable, or the constant in this case. Although it's not really a constant. Well, constant maybe across the draw call possibly, but well.
Is it always a double value?
Why the value is double?
Or is that
I don't
just a
think this is
placeholder?
push constants though.
Surely not.
That's crazy. Well, let's try it anyways, I guess. Let's try it anyways. Let's see GFW get time. And surprisingly, it's double too. So I guess this is the whole purpose of this. Maybe is to pass time around. Maybe.
I always found it weird how like the CPU like loves to work with doubles, but the GPU like loves to work with floats. So it's annoying. You have to convert always.
Yeah. Well, with floats, I guess you could do more operations using those registers, those crazy registers. But I don't know. I don't have much experience with that. So where do you actually put this? Constants, I guess here maybe? Oops.
If I were to guess, floats save a lot of power compared to doubles because it's half the amount of lanes per.
But then you have problems on precision.
Yeah. But like that's pretty small. Like a 32-bit float versus 64-bit float. You have to
for big worlds, you really want doubles though.
Yeah, like Minecraft, you would see like all the artifacts way out in the yard, like 32 million blocks out. But but yeah, that's 32 million units out. That's a lot. That's pretty far.
Yep. Constant entries.data. Let's go. Is there anything here? Not really. Okay, so we have done this. Now, how do we access it? Let's say, and I would guess I need to set the constant in the draw call. Maybe. So let's see, render pass dot draw, or like set constant. Ooh, there's only blend constants here. I'm really confused. I guess maybe those constants are actually specialization constants in Vulkan, not really push constants. Yeah, I think so. Maybe. So not really what we want, probably. Yeah. I guess these are like specialization constants. Okay, anyways. Never mind. So basically you could make the same shader, but it's kind of like preprocessors. So you could use the same shader code, but then have different path and crazy stuff like that. But anyways, never mind. Let's remove that. Let's try, well, we're gonna use right now the uniforms. Okay, device limits. For a tutorial, really don't need to bother people with these quirks of limits and stuff, but it's nice to know though. In order to animate our scene, we create a uniform called uTime. Let's go. Each to refacts uniform variables with a U, so that it's easy to figure out and read in a long shader when a variable is a uniform rather than a local variable. Okay, fine. Alright, so you just say var global variable. Okay. Yeah, I don't know much about WGSL, so I really have to read this. Which controls how the variable is stored in the GPU. Okay, so we have to do it this way, I think. Now we need to tell which buffer the uniform is bound. This is done by specifying a binding index. The binding. You will then define the C++ code which buffer is attached to binding 0, and actually bindings are organized in bind groups. I would guess bindings maps to Vulkan the scripture binding, and bind groups maybe the scripture sets. So I would guess. So the binding is uniform is specified by also providing the group attribute. Okay. I see. It took me some time to actually understand what the scripture sets are for. But yeah, I will try to give a description for it when we get to it. Anyways, bind group, binding. At least from what I learned, I still don't really know much. But anyways, we move the scene depending on the time. Okay, great. Okay, let's add this to our shader. I would guess I could add it, let's say here. Group binding 0 or uniform, or we could add it on top, but I always like the types to be there. So anyways, group 0 binding 0 for our uniform, and then uTime time. And then here we could do something, let's say okay, let's see, times, let's say times sign of something pretty simple, sign of uTime. Right? Yeah, I would guess that would work maybe. With a trigonometric function, be aware that the position is a pointed circle. Yeah, I know. Okay. Now let's create the uniform buffer. Okay, let's try to figure it out ourselves. Vertex buffer. There you go. Okay, let's add a new buffer here. I would probably put these in a struct, honestly. Maybe, yeah. But anyways, so here we got uniform buffer. Great, let's go. So vertex buffer. Though maybe, I'm not sure about how WGPU works or how it does its stuff, but maybe it could be better if we group these write buffer commands of the queue somehow. Not sure, but yeah. Anyways, let's just do it simply. Size bytes of vertex data value type. Okay, so right now I guess we would have uniform data, right? Yeah. A uniform data. We would write only the time in this case. Okay, map that creation false create buffer. Well, in this case it would be maybe useful to actually persistently map it. But anyway, let's just go with the tutorial. Okay, Q write buffer. So let's have possibly some struct for uniforms, I guess. Oh, model view projection. Let's start simple. Float time, I guess. Right. Float time. And down there, what we're gonna say is what's happening here. Okay, let's actually remove this. Let's copy this instead. And let's see. So instead of index, probably want uniform. And then the size in bytes would be size of decal type index data. Oh, I actually could do that. Hold on. Figured that a way. Instead of doing size of decal type vertex data, value type, we could probably just say size of decal type. Yeah. Probably. But I'll have to try, honestly. So I don't bump my head on the
Does your
wall.
IDE support like constant evaluation when you hover over, when you mouse over something? So like when you hover over size of, does it give you the actual size
Doesn't seem
when you
like, but
hover
there
over?
could be some setting for that.
Uh, like even Eclipse has that feature. Even Eclipse
Yeah,
has
there
that
could be some
feature.
option for that. I don't really mess with with it too
It's
much.
super useful because, well,
Yeah, that's true. Though I've
like I
seen
use
it
Visual
before,
Studio
but like I don't know. Uh,
for things like that.
or maybe let's see. Hold on. What if I?
But I guess C++ is probably a bit different than C, so it might not be able to always be able to compute it
Possibly.
at compile time. You'd have to probably go into the settings
Yeah, I don't know. What is it
to see if
called
it's
exactly?
available.
Constant time evaluation?
Constant evaluation. Let's see. Constant.
Doesn't seem like.
Constant expression evaluation. June 20. It looks like they're available, but how do you enable them?
Okay, hold on. Constant expression evaluator C line. Let's see. Yeah, there's nothing there. Anyways, let's just go ahead and try this out. Size of decal type vertex data. Though this could go wrong when it comes to, like, let's say a vector. Though it should probably work just fine on an array, because on a vector it would just gives me this size of the in the stack. Yeah, maybe. So I gotta be careful about that. But anyways, settings preferences editor code editing quick documentation, huh? Quick documentation. There you go.
Oh,
It's
it looks
actually
like it's
on.
already on.
Yeah.
I don't know. I just wasn't able to evaluate that. Control Q is also a shortcut to open it up. Control Q.
No,
Nope.
doesn't seem to work. Oh, hold on. Yeah, it just gives you this.
Sad.
Anyways.
But like when you hover over size of, try the size of.
Where is size of?
When you're trying to do the
There
decal
you go.
type size.
No, doesn't work.
Sad.
Yep. Size of
Oh,
bytes.
with the chat.
So what's up with this? Okay, so size of decal type index data. I think, let's see if this actually works. Though this wouldn't work for, let's say, a heap. Like any heap object like vector. Because it would take the wrong size then. But for an array, this should work, I guess. Ooh, interesting. Why? Let's see. Go back. Oh my god. Index. Okay, so let's see now. What in the world is happening here? I haven't done anything. Oh, my bad, my bad. I have actually changed this. Yeah, I see. Let's actually count this out. And
Oh wait, did you enable errors?
I don't know how to, honestly, using the C++
Oh.
wrapper. But there you go. Now let me try first that thing that I've talked about, which is size of decal type. It should work in theory. Well, let's see. As long as the type is in stack, as the whole thing is in the stack, but let's see. And oh, what's up with this? Why there is two? Bruh. Oh, I'm confused. Alright, so yeah, this should be fine now. I should probably create its own kind of class or even at least a function, but anyways. So now let's try this. Oh, oopsies, hold on, I forgot something. Bruh. So yeah, here, index data. And let's go. Size of decal type index data. Okay, let's see if this works. There you go, it actually works. As long as it's an array. If it's a vector, then a big no. But anyways, at least in theory. So now let's try to add a uniform buffer. And let's actually get back the binding and stuff. So binding times sign of u, well, n u time, yeah, u time, just u time. And let's see what's gonna happen now. So we're basically gonna create another buffer. And did we add the uniform? Yeah, there we go, we added the uniform thing. And now decal type of uniform. Well, basically we're gonna have the uniform data. It's gonna be, yeah, I see. So it's gonna be uniform const GFW get time, isn't it? Oh, what I'm doing, uniform. And there you go. Double to float. Okay. For now, let's just go with the float. And size of bytes. We're gonna go with decal type of uniform. Or we could just say uniform, honestly. Yeah, we could just say uniform here instead. Because it's not an array or something. In fact, coming to think about arrays, I wonder about something like index data, let's say. No, anyway, never mind. Okay, so size of uniform. Descriptor, we're gonna go with uniform here. Size of bytes, we're gonna create the buffer, and then we're gonna do instead uniform buffer. Oopsies. There you go. Okay, so we got the uniform buffer now. Create buffer, write buffer. Well, here we gotta say uniform. Then here we're gonna say slice bytes, and that's it. Okay, great. So this should be it for creating a buffer. Next up, okay, map that creation files, blah blah blah. Okay, then use write buffer to upload. We have already done that. Binding configuration, pipeline layout, yeah. So we gotta add it to the, oh, we gotta create a pipeline layout now. I see. And then we also gotta configure the binding layout, which, where this goes. Weird. Anyways, usage. And then you set the bind group. And then every time you have to write to the buffer, which is, I don't know. Let's see. Yeah, it's probably better to just like static, like persistently map the buffer if possible, and just write to that. But we'll see about that later. Okay, let's try this out. So first of all, we gotta create the pipeline layout. Let's see. Probably before the pipeline. So where's the pipeline? There you go. Let's see. So pipeline layout, I guess const pipeline layout device creates pipeline layout, and here we probably need a descriptor, I guess. What this needs, probably. Really hate the fact that C++ doesn't have the ability to like just pass in the struct here. But anyways, because it have an address, though in C you can. So what's going on here? Let's see. Descriptor, bind group layout count. So yeah, you have bind group layout count and bind group layouts. Okay. So we're gonna create a little array, which is gonna contain, yep, basically. And here we're just gonna say entries.count, I guess. Well, size actually. And here we gotta say entries.data, isn't it? Oh, it's actually bind group layout, not layout entry. Shame. Group layouts, okay. Let's call them bind group layouts. Okay, what's up here? Oh yeah, we gotta create a new bind group layout. Yeah, interesting. And then you gotta give it another descriptor. Damn. Anyways, bind group layout. Okay, what's up with this? Weird. Yeah, GitHub Copilot is just going crazy here. Anyways, layout binding. Well, I'm gonna do it myself. Bind group. Layout descriptor, please. Bind group layout descriptor. And then the binding count. Oh my god, too much. That redirections. Visibility. Okay, here you tell it which state you want it to be visible to. Well, in our case, in our specific case, we're using in the vertex, so let's go with that. Binding count. So let's say another array. GPU binding. Oh, what is that? Bind layout binding, I guess. Yeah, okay. What's up with this? Super confused. What? That is crazy. Anyways. Okay, bindings, what it is. Spine group layout entries. So std array, bind group layout entry, of course WGPU. Being helpful or useless. Is code palette being helpful or useless? In this case, it's more useless. And in fact, even hurts my productivity at this point. But the thing is, it's understandable because I'm using the C++ wrapper of the WGPU. Though if I was using, let's say, the C wrapper, it may have helped me more, especially in C, because more people, use that. And especially the fact that the API is not stable yet and there's a lot of changes. So as for example, this has dynamic offset. It may has, well, in fact, that's not the problem. Anyways, whatever. So bind group layout entries. Now we're just gonna say bind group layout entries dot size and entries dot data. Okay, this doesn't even exist. It's called entries. And what's up now? Come on. Yeah. And what's up with this? Oh, you don't have that entry count, and then you have a label. Yeah, that's it. Okay, now what's up? Size of has dynamic offset. Don't need this. Minimum binding size is uniform and has dynamic offset or not. Yeah, that's it. Type uniform. Okay, great. That's the buffer. Binding 0, correct. And now in our pipeline, we have to use it. There you go. Layout. Bruh. Yeah, it doesn't have access to it. Yeah, I see. So great. Now actually we're just gonna say pipeline layout is equal to that basically, and let's go. Now pipeline layout in here. this is super annoying. Anyways, so that's it for the layout, I think. Now what's next? Now we probably gotta change the draw call. Yeah. So, well, basically you gotta do it here. Okay. So maybe after setting the pipeline, and maybe we need to also set the pipeline layout, maybe. This part's boring, gonna be right back. All right. Render pass set. Yeah, I just set the bind group, seems, or bind, yeah, bind group. Here the group index and dynamic offset count and dynamic offsets. The group index in this case is 0, and the bind group, what's happening here, of non-aggregate type group. So let's call this bind group, I guess. And let's just say bind group. Well, it's called WGPU bind group, I guess, maybe. Okay. No. What is that? Set label. And that's it? What in the world? This is super not understandable. Oh, what? Oh, I see. So the bind group should also be stored. So pipeline layout, and we need the bind group here. The bind group layout, is it? I don't know. Let's see, bind group layout, and no, it's not. Bind group, probably. Okay, no viable construction to what? This is weird. Set bind group, what it takes. Bind group, okay. So I don't know why it's... Oh. Let's go. So there you go, bind group. And now we're just gonna say bind group here. Oh my god, finally. Damn. And the other thing would be is when we create the bind group, we have to store it. But where I have created it, no idea. Or did I even did? Okay, let's see what they have done here. Create bind group layout. Create bind group. Okay, where I'm doing create bind group. What? Oh well, bind group description, entry count, layout. Okay, so basically I have created the layout, and now I probably need to create the actual bind group. Come on, what's up? this. Well, bind group is equal to device. There you go. Create bind group. And here we need that descriptor. Bind group descriptor. Super stupid. Bind group, well, bind group descriptor. Well. Bind group entry, we already have that. No? Not really. Oh, well, that is crazy. Let's go to the cd array. Yeah. Okay. Pipeline layout descriptor. Well, not really. Where is entries? It's bind group entry. That's layout entry. Okay. Bind group entries, WGPU. Bind group entry, bind 0 buffer uniform buffer, offset 0, size of uniform. Great. Okay, and here we gotta do entries.data. Here bind group entries.size. And let's hope that's enough. Oh my god. If not bind group. Okay, it's working, but we don't see any animation here, interestingly. Well, yeah, that's right. Because we're not writing to it, we're not changing it though. So we have to change it every frame. Okay, let's see. So where he does change it, let's see. He's doing it here, but where exactly? Update uniform buffer. He's not saying though. So yeah, I'm just gonna do it wherever I want. So let's go. I guess we could do that just before creating the render pass, maybe, or before the command encoder even. Why not? Q dot write buffer. Okay. Uniform. And I guess so. And let's go. We got an animation. Using the time. Oh my god. I gotta take a break for now. Just 5 minutes or something like that. I'm gonna come back. Be right back, 5 minutes. Okay, hello, back. All right. Let's go. Is the stream fine? The mic seems to be on, the camera seems to be on, great. Alright, I found that mastering graphics programming with Vulkan. What do you mean? Okay, so we got this uniform stuff working. Mastering graphics programming Vulkan. This book goes through AAA game engine creation. Which book? Which book? All right. Great. Now, one thing that I think about is this descriptor that we change every draw call is probably better to be persistently mapped, because we're gonna write to it every single frame. In fact, yeah, or in fact sometimes even every single draw call. But in this case, at least we're gonna have separate uniform buffer for maybe, or in fact uniform descriptors there or something. I don't know, we'll see. But either way, for this particular case, for global stuff that is changed in every single frame, but that is global through all the draw calls, these would probably better be in one buffer that is persistently mapped. So I don't know if that how that would work on WGPU or WebGPU, but let's see. That would be interesting to try out. Let's see. Okay, so where we're creating our uniform buffer, I guess here. But why we're getting, oh, well, we don't really need to create a write buffer here because we're writing for every single frame. Yeah, pretty much. So you don't need that. Great, so what are we gonna do? Okay, so here there is mapped at creation, I believe, which could say true. But now how can we, there you go, get mapped range and get const mapped range. Well, I want to write to it, so it's probably get mapped range is what I want. And then here, size and WGPU whole map size, interesting. So yeah, fine. But what this would return, this, oh, let's go. This gives us a void data, amazing, oh my god. So let's say uniform data. This gets me so excited. Okay, uniform data is equal to get uniform buffer to get mapped range, and of course this would be here in the app, I guess. So after uniform buffer, we could say void. Well, not necessarily void. In fact, we could just say uniform, really. Data, right? But what's up with this? Oh, it doesn't have access to it. I see. So for that, well, hold on a second. app.hpp. It's gonna be called uniform data actually. And the other thing we'd do is that we would go ahead to app.hpp. Well, actually app.cpp, and let's grab that struct uniform. Let's put it here. In Vertex app, well, not here. app.hpp, let's go. All right, so now this should work out. So now we got a mapped range, right? Let's see what's up. Assigned to uniform for incompatible type void cast expression. And this should work just fine, hopefully. So all right, now if everything have worked just as I expected, we could just write to that data and then it would be synchronized without any problem. So instead of queue.write buffer every frame, we would probably be able to just say static cast g of w get time. So how are we gonna do that? Well, yeah, we're just gonna say uniform data, hopefully, time static cast float g of w get time, and let's go. This should work in theory. Let's see. Oh my god, if this works, that's gonna be nice. Ah, I knew it can be this easy. Let's go. So something is not right. Okay. So uniform data time, that doesn't work for some reason. Well, I do remember that he have talked about this before in the tutorial. I think, let's see, playing with buffers, I guess. He talked about memory, hold on, mapping. Yeah, exactly. So let's see. By adding the map read flag. Oh, okay. So yeah, that's probably what I'm not including. So if we go to buffer usage, where is it? So here, basically, instead of copy DST, probably what I need here, because I'm not going to be using the queue to copy to it anymore. I gotta use either map read or map write, or maybe even both. I'm not sure if that's possible, but yeah. And in my case, I'm gonna write to it. I'm not gonna read to it, none of that. So, and hopefully that should fix it. Let's see. That would be nice. Let's go. Oh, okay. Doesn't work still. I don't know. Map right. The buffer usage map read flag is not compatible with copy src one, so make sure to not have both at the same time. Can now call the buffer mapping. Buffer map async. The function on buffer2 map is defined here as a lambda expression, but I don't need this. I've already said that it should be mapped at creation, I guess. It's no standard solution. Buffer map async. Okay, I guess maybe I'm missing this buffer map async thing or something like that. I really don't know. But in theory, I'm saying that it should be mapped at creation, so that should work just fine. Unless maybe if for whatever reason it also needs copy DST, I don't know. Let's see. Though that shouldn't really be the case, but I don't know. Okay, so that doesn't fix it. Alright, so map right, map the creation, then we're getting the map to range. Though if not uniform data, then throw an error. No error. Okay, what about uniform buffer? Okay, let's see what else. Get map state, get usage, get map async. Oh, okay, so there's this map async function. But I don't really need this, do I? I mean, I set map that creation, but weird. But I guess let's try it anyways. So app, if static cast status not equal to success, fail to map, and then say, app uniform buffer in map with the, let's say, I mean, I don't really have anything to do here. We're getting the user data. Well, yeah, we don't really need anything here. Just say no. Don't even need the app here. In this case. Expected 5? Why expected 5? This is crazy. Really don't get this. Uniform buffer map async. So it needs WGPU map mode. I'm gonna map it to writing. And the offset size, of course. The size would be the size of uniform. And the callback would be that guy. Reg. And user data null PTR, right. And let's find out if this would work by any chance. I'm not sure if I'm supposed to call this every frame or what exactly. But let's see. And use parameter. Who cares? Still nothing. Weird. Okay, what if I map async every time, like every frame? I don't think that's how it's done. I don't know why it's not using map at creation though. Yeah, it's not saying why not to use it. And other than that, copy DST. Map read and copy DST. That doesn't make any sense. Let me make sure I'm doing it correctly, I guess. Oh, hold on. Oh my. Well, no, it should work. Yeah, no, it should work. I don't know. What about map that creation false? Oh, hold on a second. Where I'm mapping, where the map async is. Ooh, I got an error. Yeah, this time I got an error. Interesting. Because I didn't call map async. So where did I call map async? Oh, I have removed it, I guess. Or what? But that actually tells us that it is indeed mapped. So what is the problem? Maybe the place where I'm setting it is wrong. What happens if I set the bind group or something and then write to it? I don't think this is how it's supposed to be. Yeah, no. Well, no idea there. And anyway, let's just go back to what was working for us, which is just very dump right into it every frame. Yep. So this was the one that was working. Redefinition of struct uniform. Okay, let's go back in time on this one too, I guess. I mean, we do need the uniform data now. Yeah, we don't. Okay. All right, let's see. Okay, we're back into the working state. Though I'd like to initialize a repo here, honestly. So git init, git branch dash m main. So I could call it main. And let's just commit this stuff. So we don't have to do control Z, and crazy stuff like that. Oh my god, inverged file. Let's look at that. That is crazy. Anyways, so at build, I'm gonna add it to my git ignore. Now I don't have much inverged files, so we have this. No need for that one. Okay. This. And yeah, that's it. So add all of these. Add to VCS. And oops, I have added them all. Weird. Project defaults coded. Well, anyway, who cares? We'll just commit them all. So commit files, let's go. So I'm gonna call this, well, I guess animated two triangles. Commit name. Oh, well, are you kidding me? Oh well. Okay, well, let me see. Hold on a second, let me actually set this up. GitHub. And let's see, where's, that's my name right there. And the email, who remembers? Where's my, oh well, let's just check this out here. Settings, okay. Come on. Bro, this is crazy. Emails. Okay, finally. Damn. Let's go. Okay. And now that should have worked. Yep, there you go. Okay, well, right now I have set that up. Nice. One thing real quick. Okay. And yeah, there you go. We're back. Great. So now what? Now what? Okay, we got that animated two triangles. Let's go back to the tutorial now. And let's see what we got. Shader uniforms. First uniform, we probably have gone through all of this, I'd guess, and more uniforms. Okay, so in order to illustrate, there are multiple ways. Shader side, my uniforms. Okay, I could turn that into a struct there too, which is nice. I'd surely go with that. So let's go to here, then let's have that in, how does it do that? Okay, so like this, yeah, uniform. Oops. Okay, struct uniform, and like you say location times 0. I don't think, yeah, no, you just say time float like this, and then how do you do that? Yeah, let's change this uniform, and then here, oh, what's happening here? Is a reserved keyword. Okay, yeah, let's call this uniform. I don't know what to call it. So dot time, and that should work just fine, just like before, just a bit more flexible. Interesting. Uniform dot time. Oh, maybe this should be f32. There you go. Okay, let's go. I really want to know how to check for errors, but we multiply the scene's color with our global uniform. This is one possible use of the color uniform among many others. I see. Gamma correction. Buffer. On the CPU side, we define the very same struct. Yep. Color. Yeah, we're already doing this. Oh, I see. So like if you want to update one individual thing, interesting. Binding layout, visibility. Yeah, I see. Memory layout constraints, alignment. Yeah, if you look at the uniform, you can see. Wrong, not a multiple of size of VIC4F. Yeah, I see what they're talking about there. Offset 0. Okay. Size of VIC4F. Warning, if you use the offset of macro to perform partial update to uniform buffer, you're good to go. But if you did not, make sure to reflect this reordering of the fields everywhere you relied on it. Alright, let's go. What else? Padding. Another constraint uniform types. Host shareable. Pad. Okay, let's add this. That's great. It probably would fail actually because we don't have that. We didn't add the padding yet. Oops, not here. App.cpp. Let's go. Here I'm gonna say static. Assert that the uniform alignment is 16, which is not correct in this case because we gotta add some padding. So to add that padding, we would do, well, we could say float pad 3. Yeah. Okay, so we could say like vic 3 padding. Or actually no, let's not use that. Let's just use an array, simple array, right? So how do you do this? Or can GLM help us here actually? Doesn't seem like if I say 1 comma and I say like maybe time here, that help by any chance? Nope, it doesn't. Okay, so let's just say padding and float padding 3. And yeah, as you can see, this actually works. Nice. Because the alignment should be at least 16 bytes, I think, or something like that, which is basically 4 floats, I guess. But I'm not sure exactly how that works, but yeah. Okay, so we have seen that providing multiple uniforms coming down by actually providing the structure multiple fields. Memory alignment constraints. Oh, nice. Okay, so he's using GLM there, but yeah, we're already using that. And let's see, what's this? Imagine you want to issue 2 calls to the draw method of a render pipeline with different values of the uniforms. In order to draw 2 WebGPU logos with different colors naively, we could try this. A first color, write buffer. First draw call, draw indexed. Index count. Okay, draw indexed, index count. And 1 in uniform.time, different locations and different color for another draw call. Different location and different color for another draw call. Okay. And then you write the buffer again. And second draw call. But why? Different. Well, why not just do all of it? Like, well, oh, I see what he's doing there. So basically, update multiple updates in one frame. Makes sense. Makes sense. So, not do what you expect. You do not re-trigger operation, rather build a command buffer that is sent at once. Yeah, I see. So the call did not get interleaved between. Interesting, I see. Said we need to use dynamic uniform buffers. Requires to be careful with the buffer stride. Yeah, who cares about limits now? Another lead limit is offset alignment. Okay, when declaring the bind group, so the buffer is dynamically offset. Okay. Oh, we can offset it between draw calls. That's interesting. The value of this dynamic offset will later pass to set bind group. Okay, gotcha. Buffer data. So basically, you'll have one buffer, and essentially you'll have duplicates of that uniform, and every one of them would contain the version that you want for that specific draw call. But yeah. Oh, so we need to get this limit if we want to use this. Though we're not going to use this now. But that's interesting to know that it exists. So do not use the last two arguments surrender pass, namely dynamic offset count and dynamic offsets array. They are the way to provide an offset that is different for different calls. So basically what they're doing here, dynamic offset, uniform strides, set bind group. And here they pass the dynamic offset. And again, they use that set bind group, the same things, but they change the dynamic offset. Makes sense, makes total sense. Two different bind groups pointing to two different buffers, but the dynamic offset approach scales better when you share a large number of draw calls with varying uniforms. Makes sense. Though I would use, oh yeah, anyways, never mind. Conclusion. I'm ready to move into actual 3D shapes. Oh my god. 3D meshes. That's gonna get crazy now. Let's see. I rolled back the part of the code about dynamic uniforms for now. Also set the offset to Vic to F. Here's a simple shape that can save in resources pyramid. Can now load the geometry as follows. Okay. Then we need to update the vertex buffers, right? This was 2. Array stride 6. You want to take a break and talk about food? I already take a little 5 minutes break, so don't forget to update the vertex input struct. Though I'm very tired, but I want to get something more. I'm tired, but I'm excited too. So this was a 2. Now it kind of works. I call it 3D yet and add in. Does not change anything so far. Right. Though send me a message if someone wants to talk on Discord, because I'm gonna remove my headset. Alright. Let's go. Times the ratio, basic transform. If you are familiar with the concept, you may jump ahead. Trigonometry, okay. Yeah, I already know what he's gonna do now. We don't need to know all of this. We could just use GLM for this. So yeah. In fact, let's try to do something about that, in fact, ourselves. Hold on. Now that we have uniforms, we could do something pretty cool, which is to have like a matrix. Though I'm not sure how it would work in WGSL, honestly. That's crazy. Well. I'm not sure if that would work. Like, if I try to say GLM projection, what it would be, or like whatever. Let me just see what they have there. Matrix. How do you do projection though? Weird. Yeah, how do you do projection? Well, anyways, let's not waste time. Oh well, shading. There's something wrong with the depth. Yeah, so as you can see, shading is wrong because we don't have a depth buffer yet, which we're probably gonna create now. Okay, the Z buffer algorithm. Pipeline state. Okay. Pipeline depth stencil. I usually only worked on 2D projects, so I guess this is my first time using a depth stencil thing or whatever it's called. That's gonna get crazy. Well, depth stencil state default. Depth stencil state. Setup depth state. Depth compare less. Is blended only if its depth is less than the current value of the Z buffer. Okay. Depth right enabled. Though I know what is a Z buffer, etc. Depth right enabled buffer. Really did want to write show fragment is blended. Let's see, must show the pipeline the depth values of the Z buffer encoded in memory. Depth 24 plus. I think depth maybe 16 is fine, not sure. I did remember something about that. I don't know. Oh yeah, it was in Godot, I guess. Yeah, let me try something real quick. Just wanna see something in the settings. Let's see. Come on, why is this super slow? There you go. Okay, so scene project settings, right? So there was something about depth. I remember. Huh? What? Or maybe shadows it was or something. Yeah, maybe shadow maps it was. Oh, it was shadow maps, I think. 16 bits shadow maps. But I don't think it's the same thing, isn't it? Yeah, it's probably not the same thing, right? No, it's not. Never mind. So 24 is probably the best, right? For depth texture. Okay, with depth, the same texture. To a potential stencil buffer. Oh, I see. Stencil buffer could be useful too. Oh, okay. Depth texture. And now we must create a texture. Render attachment. Depth texture format. Create texture. Okay, depth attachment. the shader. In the range 0, 1. Then there comes the transformation matrices and stuff like that. Yeah, honestly, I'm super tired at this point, so yeah, we're gonna leave it until tomorrow at this point, pretty much. And yeah, that was it for this stream. Thank you for watching, and see you later. Goodbye, everyone.